Hello everyone. In this podcast, we are going to compare Kapur with some of the well-known code coverage tools available for Java. There are many coverage tools like EMMA-based Eclipse plugin ECL EMMA, Jacoco, which is a Java code coverage tool, a well-known commercial tool Cover, etc. The two coverage tools which come closest to Kapur are EMMA and Jacoco, since both of them are open source and use similar techniques to instrument the code. In this podcast, we will strictly evaluate the tools based on their usability and their usefulness to software developers in their daily development activity. The detailed analysis of Kapur based on its technical features is being presented in another screencast. The link for the same can be found in the description section below. Before we go deep into the comparison, we would like to explain a bit about the data that we used for the analysis. We selected three open source projects for our analysis. OpenMRS, which is a Java-based open source enterprise electronic medical record system platform. This project has two components, a web front-end and a Java backend. While performing the analysis, we focused on the JUnit test cases, which were mainly written for the server-side Java classes. The second project we selected was another open source project, Cassandra, which is a database implemented in Java. And the last one, a simple utility written in Java, which is used to parse comma-separated documents called OpenCSV. The projects are carefully selected such that they have a small, medium-sized and large code base. Also, since the focus is on automated test cases and coverage report generation, we selected the projects which had enough number of server-side classes which could be tested using automated JUnit test cases. Alright, on to the comparison part of the podcast. As we mentioned before, all these three coverage tools are open source code coverage tools, but they are distributed under different licenses since they inherit from different code bases. Kapur is a JCover based tool and hence is distributed under GNU GPL license, whereas ECL EMMA is an EMMA based coverage tool and is distributed under CPL license. Jacoco is distributed under the terms of Eclipse public license. It was developed as a replacement for EMMA under the umbrella of ECL EMMA Eclipse project. All these tools differ also in their code instrumentation style. Both Kapur and ECL EMMA use offline bytecode instrumentation. However, Kapur injects a significant amount of bytecode which has some significant impact on execution time. EMMA, on the other hand, injects a small amount of efficient code, thus making it a little bit faster than Kapur. This also brings in the difference in the size of the instrumented classes. The size of the instrumented classes for EMMA is much smaller than the size of the instrumented classes for Kapur. Jacoco uses a different style of instrumentation, which is on-the-fly bytecode instrumentation. To do this, it runs as Java agent and can be configured to store the collected data as file. However, this makes it even slower than Kapur when it comes to performance. We feel this degradation is not that significant as long as your test cases are not too slow. However, it might cause issues if the test cases are considerably slow and the system is huge, so it includes a very large number of test cases. Same is the case with size of the test suite after instrumentation. Unless the size of original test suite is not out of bounds, the instrumented code should also be manageable. In terms of support for the latest versions, both Kapur and EMMA perform badly. EMMA project has been inactive for a long time and Kapur has not been updated since last 3 years, thus making both of them a little slow in catching up with latest versions of Java. Both EMMA and Kapur have problems when the projects are compiled using Java 1.7. However, unlike Kapur and EMMA, Jacoco fully supports Java 7. This is partly also attributed to the on-the-fly bytecode instrumentation. For the purposes of this analysis, thus we used Java 1.6 for all the three tools. Kapur focuses on lines and branches. By branch coverage, we mean the if-else constructs and the case statements. ECL EMMA concentrates on bytecode instructions and gives a good line matrix. Jacoco also offers both line and branch coverage like Kapur. In addition to line coverage, EMA also detects partial line coverage. That is, a conditional statement like if A equals B or B equals C would be reported as covered by most tools if one of the conditions passes. However, EMA reports this as 50% covered. Koba-Chura lacks this feature and marks the line as fully covered if one of the conditions passes. Overall, all the tools will highlight coverage by showing covered and uncovered code in Eclipse for you. The EMA plugin has a nicer graphic display and lets you drill down. Koba-Chura's display in Eclipse is a bit weak. No drill down into classes or visual graph of coverage is available for Koba-Chura in Eclipse. Also, some of the statistics which are available in Koba-Chura when run from command line are missing when the tool is run in Eclipse. For example, you get cyclomatic complexity when you run Koba-Chura from command line in the HTML report, but in the coverage session view it is nowhere to be found. However, this shortcoming is compensated for in Koba-Chura by an elaborate report when run from command line. This is especially good for large software development projects, since in those situations it is mostly the case that a coverage tool is built into the automated build system and coverage reports are generated right after the build is done and all automated test cases are run on that fresh build. Even though we did not get a chance to explore all the small customizations provided by both EMA and Koba-Chura, the default report for Koba-Chura looks much appealing than EMA's report when run from command line. Although Koba-Chura's Eclipse view fails to provide users the ability to drill down, the default HTML report provides all that and much more. First of all, the report is similar looking to standard Java kind of template, where all the packages are listed on the left-hand panel at the top and classes from that selected package are listed in the bottom of the left-hand panel. The actual file and its coverage are displayed in the right-hand panel, where it shows the line and branch coverage and actual file with covered and uncovered lines highlighted in different colors. It also shows the coverage count, which gives the number of times a particular line was executed in all the test cases. EMA's report in this regard has less visual appeal than its Eclipse plugin. If you invest some time, you can probably make it look better, but the out-of-the-box report that is generated by EMA is somewhat cluttered and makes it a bit difficult to find the right information easily. Of course, this is a matter of perspective and people using EMA for a long time will definitely not agree with us. But as first-time users of the tools, we found Koba-Chura's HTML report better than EMA's HTML report. Apart from graphics, it is also interesting to look a little closely at how some specific elements are handled in coverage report. The various special language features are handled differently by Koba-Chura and by EMA. When static nested classes are compiled by Java compiler, it creates a separate class file for such a class. EMA shows this class on its default class coverage report. So somehow, even if your line and branch coverage is 100%, the class coverage shows up as somewhat less if this class is not covered by the test cases. Koba-Chura does not show this class by default. It is only after drilling down that we see this class. Line and branch coverage for this class shows as NA, which means not applicable in the respective cells. The Koba-Chura style seems like a good solution since it does not confuse the developers like EMA's report, where even though the line and branch coverage is 100%, the class coverage falls below 100%. Same is the case with default no argument constructor and enums. EMA gives you the credit for covering one method and one line by showing the default constructor in the class methods. Koba-Chura, on the other hand, like the static nested class, shows the constructor but mentions its line and branch coverage as NA. Similarly, for enums, if the default enum methods like value of and values are not covered, then EMA reports the enum as 0% covered, but Koba-Chura reports it as NA. In all these cases, it makes more sense to us to mention the default constructor or default enum methods to be marked as NA instead of marking them as 0% covered, since they are the default behavior and are not something which is developed by the developer and needs to be tested. However, Emma's design also makes sense since anything which is not covered is marked as 0% covered. Overall, we feel Kobertura is at par with most of the code coverage tools out there in market. As far as getting a feel of the coverage of code is concerned, all the tools are equally good. The Eclipse report for Kobertura is a bit weak, but the detailed full report is better than Emma's. Also, the performance degradation because of addition of excess of bytecode during instrumentation phase is not that significant, unless the test cases are too slow and should not affect the productivity of the developer. So if you are looking for some tool to get your Java codes coverage report, Kobertura can be your friend. Thank you.